Hello, ladies and gentlemen. Today we are going to focus our attention on just one type of solid, and that is a prism. Okay, we're going to be looking at this both the surface area and the volume for this figure. You're going to need your notes as well as something to write with and a calculator because we're going to be dealing a lot with calculations and formula use, okay? So you should have your little flip chart because we're going to be writing in your flip chart some formulas as well as some examples. So first of all, let's think about the prism idea. I think you should write this in your notes, this vocab piece right here, um, as the heading and your prism page. When you open up the page there to the prisms, you would want to have one side devoted to volume and one side devoted to surface area. You can kind of see that where the two sides would be right there on the fold. Somewhere you need to write the definition of prism. So prism is named after the type of base it has. All the other lateral faces or the sides are going to be rectangles. So prisms are what we tend to think of as like this sort of boxy figure. But many of the prisms that we've dealt with have been the standard, rectangular prism, if you will. But there are other types of prisms. This prism would be a triangular prism. Notice that there are two faces on this prism that are triangles, but all the rest are rectangles. The sides would be the rectangles. Even though it's tipped over, it's considered to have rectangles for the sides, but the bases would be the two triangles because those are the two sides that are unique to this figure. This one would be a pentagonal prism. Again, you could see the pentagon in front, pentagon in back, but the sides here are all rectangles. So it's considered a pentagonal prism because it's named after the type of base it would have. And this one is a hexagonal prism. You can see that most of the time we like to think about them as sitting on those hexagon bases or the pentagon base or the triangle base, but that's not always the case. Just because you turn the figure doesn't mean it turns into something else. It's still a prism, it still has that as the base, and we're going to need to think about that base when we calculate the surface area and volume. So once again, just to kind of recap, if you can draw it if you want to, but let's think about what's happening. There are going to be two unique figures or shapes that make up the base. All the rest are considered the lateral sides or the side areas. In this case, they're called lateral faces. And the lateral edges would be, again, tying in that vocab from before, the edges where the sides come together. But think about these figures in terms of their name, and that'll help you identify who is supposed to be the base. So surface area prisms, we could do a couple things. We could think about the total area of all the surfaces of the solid. So we could think about base areas plus lateral areas. So if we had to go ahead and calculate the surface area of this prism, we could go ahead and find the area of all the sides and add them together. You may have even taken a look at it in terms of its net, like how you could decompose it into all the rectangles that make up the figure. Now that you have that experience in your previous math knowledge, let's go ahead and think about how we can turn this into a formula to help us, efficiently evaluate the surface area. So we're going to consider developing a formula for this. Let's think about this first. Don't write this part down. This is how we're going to get to that formula that I do want into your notes, okay? So let's consider this prism. It's just a simple rectangular prism. If I were going to go ahead and decompose the surface area, I would think about this as being basically the area of the two bases, right? So I'll have area of two bases plus area on the lateral sides, okay? So on the sides. So area of the two bases, so I'd have 2 times, how would I find the area of the base? Well, this is a rectangular prism. I can see that this side and this side could be considered as my two bases. And all the rest of the sides around the outside are, again, other rectangles. So we could consider those as the lateral area. So how do I find the area of this base down here? Well, I would take length times width, right? That's no big deal. I have 2 of those. I can understand how that would be easy to calculate. Now, how about the area along the sides? Are they all the same rectangle or are they different? Well, let's think about that. I would be adding together the area of all the sides would look something like this. This rectangle right here would be W times H. And then on the back, I'd have a rectangle of L times H. So I'd add that as well. And then on the left-hand side here, I'd have a rectangle of W times H. And then in the front, I'd have a rectangle of L times H. Now, what do I notice about all those? They all have H in common. H is just the height. So I could factor out the letter H and write this as W plus L plus W plus L. If I factor an H out, that means I'm dividing an H out of all of those terms. I'd have W plus H plus W plus H. Oh, I'm sorry, W plus L plus W plus L. There we go. Factored out the H. So what could I say about W plus L plus W plus L? Well, look at where the W and L are on this figure. They are the perimeter of the base. So another way to think about surface area, guys, would be to consider that you have two areas of the bases you need to find. So maybe we would use a, separate symbol for area of the base, like maybe a big capital B, plus, and we know we're going to take H, which is the height of my prism here, right, times the perimeter. Now, what is it perimeter of? It's the perimeter of the base. So deriving a formula comes from taking a look at it in sort of that algebraic sense, and we can compare and see how we could simplify the process a little bit by just using a formula that in essence would give us the areas of all 6 sides added together. So I would finish this formula by 2 big B plus perimeter of the base, we'd probably call that capital P, and then times the H for the height. So that is the formula you need to write. Oh, your pages are different than mine. In the Prism beautiful page there, on one side for surface area. Surface area is 2 times area of the base. That's what the big B stands for. And then plus perimeter of the base times the height. It will always work no matter what kind of prism we have. I'm just going to write that in there. So we remember that big capital P and capital B represent perimeter and area of the base itself. H is the height of the prism. And that is always assuming that it's sitting on its base, okay? So now let's use this formula to do 2 examples. So near where you wrote this formula, maybe you want to put a box around it or something, so you can note that that's a big deal. We need to go ahead and draw a couple examples inside there. Here's the first example. Find the surface area of the right prism. The right prism just means that, it would stand upright and at 90 degrees if you set it up on its base. Okay, so let's take a look at this beautiful triangular prism here. Wouldn't it be triangular? These 2 figures are the 2 sides that are unique. The rest of the sides are rectangles. So this is a triangular prism. So in order to find the surface area, I need to do 2 times the area of the base plus the perimeter of the base times the height. So I need to be able to find the area of a base. Now this shape right here would be the base. The base is not always what it's sitting on, guys. The base in our case here denotes the type of pyramid, or sorry, the type of prism it is, and pyramid later on. So we need to go ahead and find the area of this triangle. Now to find the area of that triangle, we know we do 1/2 base times height for the triangle. The base of the triangle is 5. What would the height of this triangle be? How tall would this triangle be right here? Well, let's think about it. If it was an equilateral triangle, this would be 60 degrees, and this would be 2.5. So this would be, the long leg would be 2.5 square roots of 3, or 2.5 square roots of 3 tall. So I can go ahead and fill that in. And now that I know that the long leg, again, tying in that 45, 45, 90 there, I know that long leg, and that is the height of my triangle. So I can go ahead and calculate the area of this whole triangle here. The base is 5, the height is 2.5 square roots of 3. So I'm going to type in 0.5 times 5 times 2.5 with a square root of 3. And careful to, oops, I'm having calculator malfunction. There we go. Close my parentheses. And you should get an area of 10.8. So roughly the area of that base is 10.8. So I know that 10.8 goes right here. So I have two area of those bases. You could see that there'd be another one of 10.8 in the back. And yes, now I could find the area of each rectangle on the side, or I can just do the perimeter of the base times the height, and that would give me those same three rectangles total. So the perimeter of the base, remember that this is the base, okay? The perimeter of the base is 5, 10, 15. And then the height of the prism, assuming he was standing on his base now, so we have to picture this guy going upright, this would be his height. So now if we find that surface area, 2 times 10.8, and again, you can go ahead and type this all in your calculator in one step if you have one of those handy dandy scientific calculators. It will do it all in one step and you don't have to type several steps in here. But if you type this all in, you get a surface area total of 246.6 in centimeters squared for surface area. Okay, so let's do another example. Find the surface area of this figure. So this is more of that rectangular prism that we're talking about. You can see that it's made up of two bases that are rectangles, as well as all the sides are rectangles as well. So a rectangular prism. So this one's a little bit easier. We can go ahead and do 2b plus ph, 2 times the area of the base. The area of the base in our case would be a rectangle, so we would take 4.9 times 6.15 to get the area of that base. So 4.89 times 6.15 to find the area of that base. And we get 30.07-ish, okay? And then we can go ahead and find the perimeter of the base. So perimeter of the base, 4.89 plus 6.15 times 2, or just keep adding 4.18 plus 6.15. So 4.89 plus 4.89 plus 6.15 plus 6.15. We go ahead and get a total perimeter of 22.08. And now what is the height of the prism? Well, that's 4.07. It's sitting on its base, so we don't have to imagine turning it over. We can go ahead and just take that base amount and use that as, or that 4.07 as the height. And once again, you can type this all in your calculator very carefully to ask it what you want there with parentheses. If you use those parentheses, it's very handy here. And you get a surface area of approximately 150. Okay, so 150 centimeters squared. Now, depending on how you round in there, yes, you're going to get different surface areas depending on how you round it along the process. So you want to be just checking your work along the way and making sure that you have something that makes sense. So when we're talking about surface area, we're talking about adding up along the outside all the areas totaled. But when we talk about volume, we're not talking about how many square inches or square centimeters. Now we're talking cubic centimeters. So imagine filling a prism with little centimeter cubes like you see here in this illustration. We're asking how many of them could fit inside the prism. So to think about that, we're thinking of filling the base along the bottom with centimeters cubed, or cubic centimeters in this case, or cubic meters in this case. So this idea of filling the base layer, so filling the area of the base, and then you'd have as many layers as you have height. So it's no wonder that the volume formula for a prism is talking about finding how many cubic units fit in there by figuring out the area of the base first and then multiplying it by the height. So our formula for prism volume on the second half of your little flap there, guys, we need to write this formula. So volume equals area of the base times the height. Again, capital B means area of the base. A lot of times in earlier grades we're taught that volume is length times width times height, and that's great if it's a rectangular prism, that works. But all other prisms it doesn't work. So think about filling the base area with cubes and then multiplying by the height of that figure. So remembering again what each piece stands for, we're filling the area of the base first, and then we're multiplying it by the height as if we're filling this whole figure up with little cubes. So let's do an example or two of that. So let's find the volume of the right trapezoidal prism, and we're going to round to 2 decimal places. This is what it looks like. So notice that in this figure you have a lot of rectangles along the sides. But this is a trapezoid as well as the back face is a trapezoid. And because of that, it's called a trapezoidal prism. That means the trapezoid is considered the base. So we need to find the area of that base. Because the volume formula says find the area of the base times the height of the prism. So the area of the base we would find by finding the area of the trapezoid. 1/2, we would add the trapezoid's bases together. So we'd have 6 plus 9, and then times the height of the trapezoid, 7. So this gives me the area of the base, or the area of the trapezoid. So I'd add the 6 plus 9, and I'd get 15. So I have 1/2, 15 times 7. So 0.5 times 15 times 7 gives me an area for the base of 52.5. So the volume is 52.5 for the area of the base times the height of the prism. Now remember, the catch with the height always is, guys, you need to picture it on the base if it isn't on the base already. This is a trapezoidal prism that's been kind of turned over onto a different side than he should be. He should be setting on the trapezoid. And if he were turned over sitting on the trapezoid, then this would be how tall it is. So we're going to go ahead and fill that in for the height. So we'll just multiply that by 4, and the total volume is 210 cubic inches, because we're talking about filling it up with little cubes, not squares, but cubes, three-dimensional. So let's take a look. One more example here, and then we're done. This is an example of how you can find x using a volume. So it says find the length x using the given volume. The volume of this is a a triangular prism. The volume is 360 cubic feet. So let's go ahead and figure out what we have going on here. This side would be 8. We need to figure out the volume by finding the area of the base times the height. We're just going to plug in the values we know. We know the volume is 360 already, so we're not actually finding that. We need to find the area of the base and multiply it by the height of the prism, which in fact happens to be x here, and that's what we're going to try to solve for. So we need to find the area of the base. The base is this triangle or this triangle. They're both the same. Notice it's a right triangle. And this would be 8, this is 17. So in order to find the area of a triangle, I do 1/2 the base of the triangle, oops, I don't know it, right, times the height of the triangle. So I need to go ahead and do Pythagorean theorem to find this base. So 8 squared plus a squared, or b, or whatever you want to call it, and I can go ahead and solve that to find the length of that base of the triangle, if you will. So I end up taking 17 squared minus 8 squared and then square rooting that answer, and you get 15 for this base. So I know the area of the triangle is 1/2 times 15 times 8, or 15 times 8 divided by 2, if you like doing it that way. So we get a base area. Just rewrite that here. We get a base area of 60. So the area of that triangle is 60. So if I know that the base area is 60, what I really have in my equation then is 60x. 60 times something gives me a volume of 360. So if I go ahead and divide, right, I can just divide by 60. 360 divided by 60 gives me a missing length of x. So x was 6 feet. So the height was 6 feet. So you can work these formulas forwards if you want to find the volume, or backwards if you want to find a missing length or measurement. So I want to thank you, ladies and gentlemen, for taking good notes today. You have filled out the prism sheet there on both sides with volume and surface area, and we'll do some more figures or shapes to come. Thank you again for taking good notes. Kincaid out.